tell you that the rate doubled or tripled, or it may have reduced by a certain amount. And so we need to be able to work through this, and I'm going to show you two different ways to solve this. So you figure out which one you like the best, and you go with that. Okay. Prince Charming traveled 60 leagues, and leagues is a distance in old terms, in 2 days. Then he doubled his rate. How long would it take him to go 300 leagues at this new speed? I want to solve this first by using it as a rate, the way that we've been doing our rate problems. So the rate that we have, if we were to write them both down, are 60 leagues over 2 days. 60 leagues over 2 days, or 2 days over 60 leagues. That's the rate. Okay. It says then he doubled his rate. So if he was able to travel 60 leagues in 2 days, and he doubles that rate, then how far could he go in 2 days?
120 leagues.
Do you agree with that? If he was able to go 60 leagues in 2 days and he doubled that, doubles means goes twice as far, right? Then doubling 60 would become 120. So these are the original rates, but if we double that, then the rate we just show by multiplying by 2, then our new rates would be 120 leagues in 2 days, or 2 days to 120. Goodness. 120 leagues. So these are the doubled amounts that we want to use to solve our problem. Okay, we doubled the rate. How long would it take him to go 300 leagues? So we take the 300 leagues, put it over 1, and we're going to multiply it by which one of our two rates? The first or the second one, Kelsey?
Second.
Because? Right, the leagues are on bottom. So 120 leagues on bottom. Our leagues cancel. The 2 and 120 will reduce to 1 and 60. 60 will reduce with 300 to 5. And we have 5 over 1, so I'm just going to write that as 5 days. That's one of the two ways to do it.
Is on the short way?
Probably not. I wouldn't do it that way personally. But what this is keeping the type of problem that you're used to seeing in this and working it the same way you've been doing it. Now I have shown you this other way before, or some of the parts here. So let's take a look at that and see if you like it. And it doesn't matter to me which way you use it, which way you go with it. We also talked that we can find distance by rate times time. Rate is distance over time, and time is distance over rate, correct? So we can use that type of information to help us out as well. So we know Prince Charming traveled 60 leagues in 2 days and he doubled his rate. Well, we need to find the rate originally by taking 60 over 2, and that rate would be 30 leagues per day. Okay, just dividing 60 by 2. Then we can go in here and say that his rate doubled. So if he was going 30 leagues per day and we double that, then that would become 60 leagues per day would be the new rate, correct? If you're traveling 30 miles per hour and you double it, you'd go 60 miles per hour. 30 leagues per day, doubled makes 60 leagues per day. Then it says, the question goes, how long would it take him? That's time. We're going to be using this one. How long would it take him to travel 300 leagues at the new rate? So 300 over 60 would be 50, not 50. It'd still be 5 days. I think this one is a little more direct and to the point, but the other way is more common with the types of problems you've seen and should be more comfortable with. So it just depends on whichever one you want to use. But pick one. Don't try to do one time, another way, and different time. Pick one of them and go with it. Okay, I'll show you both ways on the next one as well, so you can see that. All right. We're not talking about a length or a distance on this problem. We're talking about how much of something we can get done. How many caps can be bought or bottles can be capped. The machine could cap 500 bottles in 2 hours. If the rate of the machine were tripled, how many bottles could be capped in 10 hours at the new rate? So we're going to solve this using the rates the first time, so it won't be that big of a deal to understand that the number of bottles you're capping in an hour is similar to distance on the other problem. So let's write down the 50 or 500 bottles over 2 hours, or 2 hours over 500 bottles. That's the rate. And if we were to triple the rate, if we're able to do 500 in 2 hours, and we were to triple that rate, how many could we do in 2 hours? 1,500, because we're going to take the rate and triple it. Take it times 3. So your new rate then is 1,500 bottles in 2 hours, or 2 hours, 1,500 bottles. If the rate were tripled, how many bottles could be capped in 10 hours? So I'm going to take my 10 hours over 1, and I would multiply by, Carlos, which one of those two, the first or the second? Because? We want the hours on bottom. So the hours cancel, and then we just multiply across, because we just have ones on bottom, and that's 100 or 15,000 bottles. Okay. So that one, once you get the idea that, yes ma'am, did I do something?
Maybe I just was zoning out, but shouldn't it be 1,500 bottles over 2 hours?
Yes, right here. Crud, that's what I did wrong. I'm zoning out and I'm up in front of them. So we need to do a little reducing. The 2 goes to 1, and I'll reduce it with the 10, make it 5. And then 5 times 15 is 7,500. Sorry, kids. So 7,500 bottles would make it right. So let's look at this with the other method. The machines could cap that. So again, using distance, rate times time. The rate and time should not be a problem, but we have to substitute the idea of capping these bottles as being the distance. That's the work being done. Okay, so you might even think of the distance as being work. Okay, just as a substitute for that. So then we can find rate by taking the work over time, and time is equal to the work over rate. Okay. So we could cap 500 bottles in 2 hours if the rate of the machine were tripled, so I need the rate, which is going to be the 500 over 2. And if I reduce that down, that's 250 bottles per hour. That's the rate, the specific rate. And if that's tripled, that would mean times 3. So your rate becomes 750 bottles per hour. Then, how many bottles could be capped? That's not a time we're looking for, is it? We're looking for the amount of work that can be done, or the distance idea here. So we're going to take the rate, which is 750 per hour, times the number of hours that they're doing this, 10, and you get 7,500 as you should. Bottles.
What was that?
Raul ran 6 miles in 2 hours. Then he ran 20 miles in 4 hours. By how much did his rate increase? Carly, looking at the first part, 6 miles in 2 hours, what would that rate be?
6 miles over 2 hours.
6 miles over 2 hours. And what's that reduced to in this situation? 6 divided by 2 is 3. So 3 miles per hour. Then he ran 20 miles in 4 hours. How would I find that rate, Chris?
Which one?
If you
So you put 20 over
20 miles over 4 hours,
4.
and that reduces to
5.
5 miles per hour. So he was going this speed, and now he's going this speed. So Kenny, how much did his rate increase?
I don't know.
Huh?
I don't know. 2 miles.
Kenny, stick with me here. You can do this. He was going this fast, now he's going this fast.
2 miles.
2 miles an hour. So his rate increased by 2 miles per hour. That's all it's asking for on that one. So when it wants you to compare those rates, you actually have to simplify and reduce it down to get the actual rate. Carlos, question?
I was gonna ask a question, but not really.
You sure? Okay. And just as soon as we get done doing all this, then there's a question on your homework, I believe. What does it mean by reducing by half?
Divide by 2.
Divide by half.
Divide it by 2. Multiply by half or divide it by 2. Let's look at number 4 together. So you can have your homework sheet out, so you'll get a problem done here. Says the tram could cover 400 centimeters in 50 seconds. If the rate of the tram were reduced by 1/2 during the thunderstorm, how far could the tram go in 20,000 seconds? Excuse me. So our rate is 400
And 50.
centimeters to 50 seconds. That is one slow tram. Tram is a
It's kind of like
if you're up on a mountain and you see these big old towers that are carrying on the cables, these carts with people in them, that's most of the time what I think of a tram being anyway. Sandia Peak Tram in Albuquerque is like the steepest tram, and I rode that, and that was wicked way back when. Alright, but that's beside the point. Life experiences for me are important. For me and no one else. Alright, so here's our two rates. So we're traveling, this tram's traveling at 400 centimeters per 50 seconds. If you reduce that by half, how far would it go in 20 seconds then instead? If it was going 400 and we reduced it by half, 200. So you're actually dividing each of these by 2, or the distance by 2, to get that adjusted rate. So your new rates are 200 centimeters over 50 seconds, or 50 seconds over 200 centimeters. And then wants to know how long would it take to go to 20,000 centimeters? At that rate? Multiply that by
The second one.
Three.
okay. Okay.
Probably 20.
The second
20,000 centimeters.
10.
Yeah, seconds. Oh, I wrote the wrong thing. It's 20,000 seconds. So which one of these two do we need to use?
The first one.
The first one. So 200 centimeters times 50 seconds. The seconds cancel. I'm going to reduce a 0 and a 0 here, and then 5 goes into 20 4 times. And then multiply 2 on the 20,000 times 4 is 8. And then we throw the zeros on, is 80,000 centimeters. So that's number 4. So reducing it by half is dividing by 2. Huh? The assignment is 1 through 30. We're going to do 1 through 30 on this. Sorry. Problem set 63. 1 through 30 due Friday. You have 10 minutes, 9 minutes technically here, and you have a seminar today. And we took it pretty easy the last couple of days. As far as homework. Sometimes homework is homework.